Watch these neon cubes come alive in JavaFX, smooth rotation, glowing colors, all under 100 lines of code. Now create a new Java class named NeonCubes3D. Before we start building the Neon Cubes animation, let's take a quick look at the essential JavaFX imports that make this 3D project possible. First, we import AnimationTimer. This class lets us update the cube rotations every frame, giving us smooth, real-time motion. Next, we bring in the application class, the core entry point for any JavaFX project. This is where our program begins and where we build the scene. The JavaFX.scene package provides the building blocks of our 3D world, things like groups, scenes, subscenes, cameras, and lights. These are the foundation of everything you'll see on screen. Then we import JavaFX.scene.paint. This gives us access to colors and materials. Colors like cyan, magenta, and lime will be used to style each cube, while font materials allow us to add realistic lighting and shine. The next import is the box class. This represents a 3D cube in JavaFX. We'll create 3 of these and animate them individually. We also import the rotate transform, which allows each cube to rotate smoothly on the X, Y, and Z axes. This is what brings our cubes to life. The bloom effect is one of the most important imports here. It adds that glowing neon look, making the cubes appear brighter and more cinematic on a dark background. Finally, we import stage, which is simply the window that holds everything together. Now let's extend our class from the JavaFX application class. This allows our project to run as a JavaFX program. After that, we override the start method. Next, we create a private static class called SpinningCube. This class represents a single neon cube in our 3D scene. Inside it, we define a box object, which is the actual 3D cube in JavaFX. Then we create 3 double values, Rx, Y, and Rz. These will store random rotation speeds for the X, Y, and Z axes, so each cube spins differently and feels alive. The constructor of this class takes 5 parameters: the cube size, its X, Y, and Z positions, and the color we want to apply. Using these values, we'll set up the cube's shape, its location in 3D space, and its glowing neon material. By keeping all this inside one compact class, we make it easy to create multiple cubes, each with its own motion and style. This structure keeps our main code clean while giving us full control over how every cube behaves. Inside the constructor, we start by creating the cube itself using new box. We pass the same value for width, height, and depth, so the shape becomes a perfect 3D cube. Next, we position the cube in our scene using 3 translate values. setTranslateX moves it left or right, setTranslateY moves it up or down, and setTranslates pushes it closer or farther from the camera. These simple transforms let us place each cube in a unique spot, giving the animation depth and a nice 3D layout on screen. To give our cube its neon look, we create a new font material and pass in the base color. Then we set the specular color to white, which controls the highlight reflections on the cube. By increasing the specular power to 80, we make those highlights sharper and brighter. Finally, we apply this material to the cube, giving it that glossy, glowing surface that reacts beautifully to light. To make each cube rotate naturally, we generate random rotation speeds for all 3 axes. For the X, Y, and Z directions, we use math.random and scale it so the speed stays between 0.2 and 0.7. This keeps the rotation smooth, not too slow, and not too fast. Because every cube gets different random values, they all spin in their own unique way. This variation makes the animation feel more dynamic, more alive, and visually more interesting than having all cubes rotate at the same speed. These small differences create a richer, more realistic 3D motion. Inside the update method, we apply the actual rotation to our cube every frame. We do this by adding 3 rotate transforms, 1 for each axis. The first rotation uses Rx on the x-axis, tilting the cube forward and backward. The second uses Y on the y-axis, spinning it left and right. And the third applies Rz on the z-axis, giving the cube that subtle twisting motion. Because all 3 rotations are happening together, The movement feels smooth, multi-directional, and natural, just like a real 3D object floating in space. This method gets called continuously inside the animation timer, so the cube never stops moving. Every frame adds a tiny bit of rotation, creating the seamless neon spinning animation you see on screen. This simple update method is what brings our cube to life. Now we move on to setting up the core structure of our 3D scene. First, we create a new group object called root. A group in JavaFX acts like a container. It can hold multiple shapes, lights, and 3D objects at once. Everything we add to this root group becomes part of the scene graph, and JavaFX will render it together. Next, we build an array of SpinningCube objects. This is where the real visual part of our animation begins. Each item in this array represents one neon cube in our 3D world. We create 3 of them, each with its own size, position, and color, to give the scene depth and variety. The first cube has a size of 100 and is placed slightly to the left at -120 on the x-axis, centered vertically at 0, and placed 400 units into the screen on the z-axis. Its color is cyan, which gives it a strong, futuristic glow. The second cube is a little smaller at size 80. This one sits in the center horizontally, raised slightly upward at -60 on the y-axis, and pushed further back at 600 units on the z-axis. We give this cube a magenta color for a nice contrast with the cyan. The third cube is even smaller at size 60, placed to the right at +120, lowered slightly at 60 on the y-axis, and positioned at 500 on the z-axis. This one uses a lime color, completing a bright neon color trio. By designing each cube with different sizes, colors, and depths, the scene instantly feels more dynamic and layered. This simple array gives us 3 floating objects that all move differently but still feel like part of the same neon world. Now we loop through our array of spinning cubes, and for each one, we add its box to the root group. This step actually places the cubes into the 3D scene, making them visible and ready to animate. With all 3 cubes added to the root, our neon objects are officially part of the world we're building. Now we add a PointLight to bring our 3D scene to life. A PointLight works just like a small, floating bulb that shines light in every direction. We set its color to pure white so it enhances the bright neon tones of our cubes. Next, we shift the light forward along the z-axis by setting its translate value to -200. This places the light in front of the cubes, giving them strong highlights and a clean reflective glow. Finally, we add the light to the root group, allowing it to illuminate every object in our 3D world. Next, we create a perspective camera, which gives our 3D scene real depth and distance. We move the camera back by setting its Z position to -800, giving us a wide view of all the cubes. Finally, we increase the far clip to 2000, so every object in the scene stays visible no matter how deep it is. Now we create a subscene to hold all of our 3D content. A subscene is like a mini world inside the main window, and it gives us full control over rendering settings. We set its size to 800 by 600, enable the 3D mode, and use balanced anti-aliasing to smooth out the cube edges. Next, we attach our perspective camera to the subscene so it knows how to view the 3D space. This camera controls depth, perspective, and the overall look of the neon cubes. Finally, we fill the subscene with a dark background color using a deep blue-purple hex value. This darker tone helps the glowing cubes stand out, creating that cinematic neon aesthetic. To give our cubes their signature neon glow, we add a bloom effect with a strength of 0.35. Then we apply this bloom directly to the subscene, instantly making every cube brighter, softer, and more vibrant against the dark background. Now we take our subscene and place it inside a new group called Root 2. This acts as the parent container for everything that will appear in the main window. Next, we create the primary scene using this root group, and once again set the size to 800 by 600. Enabling the third parameter keeps JavaFX in 3D mode, ensuring our neon cubes render with full depth and perspective. Finally, we fill the main scene with solid black. This deep background blends perfectly with our glowing subscene, giving the entire project a clean, modern, and cinematic look on screen. Now we finish our setup by configuring the stage, which is the main window of our application. First, we set the title to NeonCube's 3D, JavaFX, so anyone running the program immediately knows what the project is about. Next, we attach our fully prepared scene to the stage, connecting all of our 3D objects, lighting, and effects to the display window. And finally, we call stage.show. This command opens the window and brings our glowing neon cubes onto the screen, making the entire animation come alive. To bring our neon cubes to life, we use an animation timer. Inside its handle method, which runs once every frame, we loop through each spinning cube object and call its update method. This continuous updating applies fresh rotations on all three axes, giving a smooth, fluid motion throughout the entire animation. Since the animation timer never stops until the program closes, our cubes keep spinning endlessly, creating that dynamic glowing 3D effect. Finally, we call start to activate the timer and begin the animation. Finally, we add the main method and call launch to start the JavaFX application. With everything set up, you can now run the program and watch your glowing neon cubes spin smoothly in 3D. Thanks for watching. Subscribe for more JavaFX magic, and stay tuned for the next animation.